Okay. Well, he's Bryan. I'm Jesse. We are not Peter this time. And this talk is going to be a little bit more in depth in GraphQL. I suppose most of you are waiting for that. So this is about optimizing the way GraphQL talks with the data layer. Well, actually, how it optimizes talking with the data layer, that's actually what we are getting at the very end of the presentation, the last part. The first part is mostly about what the problem really is. And for that, I will carefully explain step by step how a GraphQL query works, how you implement it in JavaScript. But it could be PHP or Python, it could be anything. But for this example, we will use JavaScript. So, let's pick a case. Imagine that you go to Schiphol tonight. I wish I would. No, just kidding. This meetup is great. Imagine Schiphol. Imagine you were going to Schiphol with a suitcase. What is the first thing you do? Okay, what's the first thing you do? You go to a flight departure board, those big screens telling you where the check-in is and where a gate is. So that's the first thing. And for that, there's a lot of data coming in. It's flights, and there are gates, and there are check-ins, and there are arrival airports, and there not their departure airports, because that's always Amsterdam. So, okay, let's bring it into, let's talk about the data model first before jumping right into GraphQL. So we need for example, SQL data model. For this, so you start with a flight. That's obvious, I think. The flight has to arrive at an airport and also depart from an airport. So you have two IDs. So this is actually, correct me if I'm wrong, a one too many and another one too many relationship. Because there are two fields. Was that right? Probably. Okay. And then you have the passenger. And the passenger flights. So the passenger has a flight ID. But the passenger has always have to fly back. So that's a many-to-many relationship. With this, I don't know if the baby is big or the airplane is very small, but yeah. Well, so this is a many-to-many relationship with a lookup table for flight ID and passenger ID. So, okay, this is pretty straightforward. We're not getting any more complex than this. Let's build the API. Okay, so we have three different types. We have the airport type, the flight type, and the passenger type. No more. The airport type contains a name, departure flights, and arrival flights. And in the data model, actually in SQL, you don't see these two fields. These two fields are actually introduced in GraphQL and called in a special way. It's not already in SQL. And they have the flight type. Well, the flight type in SQL has a name, the departure airport ID, and an arrival airport ID, but not the actual airport object. And a link to passengers, which are also not directly seen in the column, because you have a many-to-many relationship with a lookup table. So that's also a kind of dynamic field. Whoa, it went fast. Spoiled. So the passenger type has actually in SQL only a name, but you can request it. Oh, and only a name, because the flight has passenger table has a flight ID and a passenger ID. So the passenger has only a name. Well, the demo. Bryan will show a little bit of the queries.
Okay, so we built ourselves a little application.
Yes.
Is that close enough? Okay.
Maybe close to Documentation Explorer? Or?
Yeah, I kind of want to show that, like,
Oh.
for the people that listen to the you all listen to the previous presentation. So we can see like this thing on the right side is fully generated from the API we built. Like we didn't document anything; it just automatically self-documenting. So in this case, we have a couple of queries. The main thing is we have a flight and we have a passenger, and we should have an airport. Do we?
No airport? No airport.
No airport. Oh no, these are the queries. Okay. So
No problem.
yeah, I'll explain a bit later, more in depth if you want. So
These are root fields you can request. The root 5 fields.
This, by the way, is GraphQL. It's used a lot by people that like implement GraphQL backends. You can easily just write something and get data back. So I'm going to write a query and I'm going to request the flights. It also has auto-completion, and that's also based on the self-documenting thing in GraphQL. So I'm going to request the flights and I can get their names. So there's the data. It's like all the flights with the names. But for example, we also expose like the ID, so I can also request the ID if I want to. But I can also leave it if I don't need it. But for example, like, okay, a flight has an arrival airport, right? So we can request an arrival airport. And from the arrival airport, we want to know the name, right? So now in the data you can see, I'll close the documenting thing for a second. You can see now that it's also giving back like the arrival airport with their names. And I can do the same for the departure airport. That's also going to give me the departure airport for every flight. You can see here like this, okay, this is GraphQL and this is how you can use it. And yeah.
Yeah, that's pretty much it.
Yeah, that's very much it. Demo. You'll have to wait for a second though.
Yeah. More demos coming up. Oh, remote. Okay. So I will jump a little bit to the key benefits of GraphQL first. So I think to most of you it's already pretty clear, but I will run very quickly through them. The queries are flexible, as you just saw. You can ask for multiple resources in one single request. Yeah, well, every single field can have arguments. You haven't seen that yet, but some of you already know it. You can have any field, for example, the departure airports, you can pass arguments to it, for example, to filter it or something, and any field can have arguments. So it's completely compatible. Yeah, and the client decides what it gets. So, okay, that's cool. Now, when does GraphQL get tricky? Okay, well, when queries are flexible, it gets tricky. When you can request multiple resources in a single request, it gets tricky. And when a field can have multiple arguments, when any field can have arguments, then it gets tricky because so many possibilities. And when the client decides the tree, so the server is completely out of control. There's actually the same list. Oh, I see it now. Nice. Well, let's do a deep dive into the code to explain the problem a bit more. Well, let's start from the very beginning. We query a flight. Let's build this. So I define a flight query and I say, okay, it returns a string and it's hard coded to AC12 because all flight numbers are AC12. Okay, that's not really useful, but this is how a simple message communicating with GraphQL actually looks like. When you're not requesting the flight, then you're not getting the string. So the client just receives an object with key flight value AC12. But we will pretty quickly want a subselection of fields. Not only the name, but maybe more. So let's put name as a subselection in a flight. So then you see here the GraphQL string from before. That will be replaced by the flight type. And the flight type is kind of predefined object what a flight can contain. For example, name. We will get to that later. So, and the resolve will also change. It returns now an object with name AC12. But when the flight type doesn't contain the name, then the result to the client will also not contain the name. Okay, so let's glorify this. Flights, and a list. Okay, so this way you define it should be a list. And yeah, wrap it in an array, or multiple objects in an array. So this way it's now plural. But let's integrate this with this. Let's integrate this with our database because it's still hard-coded, not very useful. Okay, so we do a database call. For now, assume that it's all synchronous code because normally we would put async here and await here, or yeah, well, maybe if this returns a promise, then it would work already. No problem. Okay, so this is some integrated code. Okay, now let's get to, the integrated code just returns kind of array with 3 objects. And every object contains name, and as I said before, the arrival airport ID and the departure airport ID. Okay, so this is an example piece of data. Okay, let's take a look at flight type. Well, the flight type is just a predefined object specification. So what can the client ever receive and what can it not receive from the object? So if a field misses here, for example right now, then the name will not be in the GraphQL documentation explorer, and the name cannot be requested from a flight at all. So let's add it. Let's add a name type. So next step is that we will probably want to retrieve the arrival airport to show on the big screen in Schiphol. And an airport can contain a name. So let's add this there. Alright, so far so good. It has an airport type, and that's pretty much the same as this one, but only with the name and another name itself. Okay, but as I said, the arrival airport is not inside the flight object yet because only the ID is there. So I have kind of to resolve it. So as you see, the relationship, it's not really well readable, but it's actually a snapshot from an earlier slide that the relationship is through the arrival airport ID, and this was the object, and the arrival airport ID is in the object. So with the resolve function, we are able to transform the ID actually into a real airport object. And we have to add this resolve function because otherwise the value would always be null or undefined. Okay, so far so good. Actually, resolve functions are always this by default, but it's not really necessary, so you can leave it out. Because the root object is just what comes in from above, and this key is retrieved by default from the object. So this is the default resolve function, but you can leave it out. All right. Now is the question, if we have this query, and let's say there are 3 flights, and all the 3 flights have the same arrival airport, then according to this code, how many SQL queries would run? We have A1, B2, and C4. Hence for A. Nice. Hence for B. 4, 5, 6. Hence for C. Most of them are saying C. Okay. So I assume nothing. He's gonna demo.
Okay, so yeah. Let's take a look again at what we have here. Let me see. Okay, so we are going to do the same query as just showed. Can you still all read it? Yes. This is the same query as just showed, right? It's getting all flights, and yes, there are 3 flights in the database. and it's getting the arrival airport of each of the flights. I'll make this way one. It's just, you don't need to v1 and stuff, but I made it for the demo. So if I request these, you can see it, okay, we're calling the database without optimizations, and we have here.
Even inzoomen op de linker.
Okay.
Oh,
Oh, my ASCII
Yeah,
is going to break.
just rerun the query.
Oh, what it is, yeah. So
You don't have to read this actually.
it's not, no, it's like the count that is important. So how many queries are this? Four, yeah. So the good end was C, because like we get the flights, we get 3 flights, and for each flight we get the airport individually. Because we don't know upfront, like if we request the flights and if we're going to request like the airport. We programmed the in this demo we program it the way like if you get a flight object back and you ask the arrival airport, then it will get it from the database, but like there's no optimization, so you'll get 4 queries, and so the answer was C.
Yeah. So, sorry?
What about 3? Because you have 3 airports, right?
Yeah, we have 3 airports, but that's what these 3 are. And the flights are requested all at once because you have 1 query to request all flights. So the first for the flights and the last 3 are for the 3 separate airports. And this is with 3 separate airports for every flight. Because GraphQL goes into a flight, resolves the airport, goes into another flight, resolves the airport, and for the last the same. So this is with no optimizations.
Exactly, and so all 3 flights are from Schiphol to London Heathrow. So you'll see we have 3 flights, and it will get like the airport, which is Schiphol, 3 times, but it will get it 3 times because it doesn't know upfront like, oh, we're getting 3 flights that are all from Schiphol to. We don't know that, yeah, at this point.
Cool.
So
Okay.
yeah,
Next. Okay, so there is a solution to prevent from requesting 3 times the same airport, and also a solution for when it would request 3 different airports. Doesn't matter. It just fixes something. Let's go into it. Okay, so we have this flight type from the previous slides, and the flight type resolves the arrival airports, which causes what I explained to him, that every time you go into this object, this will be resolved, and the next time too, and the next time too, without optimizations. So let's say we don't do this call. We take a look at 2 more arguments coming in the resolve function. The second argument is just an object with arguments you can pass to this field, which are not really pointed out in this presentation. So come to me afterwards if you have questions about it. And the third argument is context, and context is actually defined top level, shared across all resolve functions in GraphQL. Context is always the same. So you can put something like caching optimization libraries into it, which is done by data loaders. So let's, for example, say we have the airports data loaders object set on the context object. We have all done that before. And then we load the airport by just giving it the ID. And with that, the data loader will just wait until all IDs are in or are given, and then it will combine all the IDs into one query in SQL, and then it will run the query once and resolve all the promises. So actually, when you have another resolve function requesting some airport with some ID, then it will go into the same query, and that GraphQL and database couple code, that is what you write yourself when you implement the data loader. It's not predefined in the data loader. So the data loader can be used with several types of databases, but it's made in JavaScript, so it's only for JavaScript or TypeScript, of course. But that TypeScript is just a layer above JavaScript. So this facts given, how many SQL queries will run now? Hands for A, 1. Okay, 2 guys. Hands for B, pretty much. Hands for C. Okay. Oh, Bryan.
Okay, let's take a look. So we go to run version 2, and
It's raining.
indeed. The answer was B, right? 2. What you can see here is like in the previous example, I'll just show that one really quick. It's getting like the apples one by one with the same parameter. I'm not sure if you can read it, but this says 2, so it's running 3 queries, exactly the same queries. And if we use the v2 that is implemented with data loaders, you'll see that it only requested that apple just once, because it only needs it that one time, and it waits until like everything is known, and it had just that number 2, that is the ID of the airport, and then does the database call to get the information we need.
Yeah.
So this is the first optimization using data loaders.
Yeah, we actually saw in production that this optimization was really necessary for most of our cases, and it was for the big part already enough for most of our cases. So let's say you have a big page, a big table of books with all the same author, then it's just useless to call for every row the same author to the database. So only a single user using the application pretty intense already result in a high CPU in the server because so many queries are run. But we thought in a REST way, or you could, maybe not REST, but you could optimize this further. So we took a look in GraphQL, in the possibilities of GraphQL and everything coming into the resolve function. Remember this one? This is the root flights query, not the flight type, but the root flights query, where we just find all the flights coming in. We take that away, and this is actually the same. Don't mind the previous one. This is still coming from a database. So you have these arguments we saw earlier. It says root value here because if this is a root query, then the root value will be probably null or undefined, because in the first queries you don't pass any root value. The beginning of the graph has no root value, and that's the reason why we call it root value, because it has no name. Then you have arguments and context, you saw it earlier, but there's a hidden fourth argument called, we call it info, but it's actually the abstract syntax tree of the current query being run. And the abstract syntax tree is kind of a JavaScript object containing all the information about the whole query being run at that time. You can, when you click through it, when you log it and you click through it, then you will see that all deeper nested fields are also in there, and their arguments and what they mean, and you get all the information up front. This means that using this information, you can pre-compose your query a bit smarter. So in this case, we could join the airports with SQL into our flights query. So I say join because SQL now, it can be any aggregation with any type of database. So this join from GraphQL info function we wrote. It's something not public yet. We tend to, but it's still still experimental and such. It's just to give you an idea that this is a possible solution. So this way, because the airport is already in the source object when the resolve tree goes into a flight, you don't have to resolve the flight, the airport, because it's already there. Because the join info from GraphQL, info, already embedded the airport upfront. You could, let's get back, you could wrap this in an if statement. If no flight.arrival airport, then do it, otherwise don't. And that way you keep this flight type compatible with with sources which did not join this upfront. For example, if you request from a passenger all the airports he's been to, then you may forget to call the join from GraphQL info optimization function, and when you forget it, you want to make sure the arrival airport is resolved anyway, not optimized, but it should be always there. So for that you could wrap it in the if statements to make sure it resolves anyway. Well, hands for 2. Almost straight. Hands for a half. Hands for 1. Cool. Okay, Bryan?
A lot of people don't know. I saw a lot less hands than like everyone. Okay, so let's take a look. Again, we'll run version 3 this time. And version 3 has like the code he just showed. And if I run this one, it kind of like how it shows. It looks like it's still 2, but it does a lot of automatically does a lot of S, like if you know SQL, like it's renaming fields and stuff. But that's one query, and it's doing it like left join here to join the arrival airports on the flights, and all it's using is like that abstract syntax tree from GraphQL. It's parsing this, and it's seeing like, okay, you're requesting the arrival airport. Okay, I'll make sure you have it before you actually are in the resolve function of the arrival airport. And that way I can also like request the departure airport. It doesn't really matter. It will just join that on. And yes, most of you probably will be thinking, ooh, that's like performance-wise, it's, but then you have like the same problem that we discussed earlier, and that you have to like limit everything and stuff. But yeah, this is a solution that works pretty well for us right now.
Yeah.
It speeds up development time like tremendously. Only thing is authorization still has to be done on resolve level of the type. So we would still have like the flight type. Yeah, you could probably show that one again.
Yeah, I'm love to ask.
Yeah. Yeah, so here we removed like the resolve, but in that resolve, like the data is known, so you can do flight.arrival airport and will be there, and you can use that information to determine if the user can actually access that data, and don't return it if you don't need to. But the data is already there, so that's optimization, and you can use like still use authorization, and at some points it's even better to do things like this, because yeah, you have more data, you have like a better way of determining what users can see and what they can't. Yeah, and it's working pretty good for us so far. So
yeah, so you can still add a resolve function, but you don't have to. You can add a resolve function to do authorization and such, but you don't have to. Okay. Yeah. Well, so this model, this is a visual representation made by the Electron app GraphQL-rover. It's very cool. You can clone the repo, run Electron, and then you can enter any GraphQL endpoint, and it will show a visual map in Canvas. It's very cool. Everything is clickable and works pretty well. But this is our model, and it's still pretty simple. You can see the relations, but it's still pretty simple. Imagine doing this with a large existing, a large product with many queries and many fields. Well, I tried one time to visualize it using D3. So I tried to visualize the GitHub GraphQL API. And what you see right here are the centers are all GraphQL types, and the dots around the center are all the fields of that type. But I disabled all the relationships because you couldn't see anything anymore. It was just one filled up circle because all the relationships going anywhere. And in GraphQL, you don't know where the client comes in, follows a path to another type, and gets out. And that brings a lot of performance issues and authorization issues with it. And therefore, this solution we made up is pretty applicable because it's just smart and it just magically joins anything you want. So we will see how it runs in production. Thanks for listening. Cool.
Well, can you do one the previous slide.
The previous slide?
Yes.
Oh, sorry.
So, yeah, I just wanted to see. This thing, imagine it's not like went through a GitHub documentation or anything to just find out what the nodes are and all their fields. This is all based on like GraphQL self-documenting stuff. So I can fill in like one of our production API URLs here, and it will show this thing like almost immediately. That's just how GraphQL works, and that's one thing that's really powerful of GraphQL.
Yeah, when you use, for example, the JavaScript implementation of GraphQL, you'll magically get one query by default. You don't have to define it. It's called the introspection query, and in the introspection query, all the data about your whole schema is in there, and that's actually the query being run by the Document Explorer when you take a look in the graphical. And that's the same query I used here to get all the nodes and try to render it in 3D. No, not 3D, D3.
I can show it really quick. I'm not sure if you want to see like the introspection query, but
the introspection query itself.
yeah, I could probably show it.
Yeah, just a network step in.
Does anyone want to see like the magical introspection query? Okay, one guy. Yeah, I'll do it for you. Special. No, it's if I just look at the network tab here and I'll refresh that page. Let me close the console.
Je kan die ook zoomen.
Wat?
Je kan daar ook in zoomen.
Oh. Zou die niet zijn, toch?
Ja, die ontstaan.
Yes. Oh yeah, it's here. Okay. So like GraphQL is requesting the introspection query to give me all like when I type here, the ID, for example. This is all as a result from the introspection query, and it's like some.
Zoom in.
Yeah, this is right.
Zoom in.
Oh, this is the result from an introspection query. Maybe you can show the introspection query.
Oh,
itself.
exactly. Yeah, I just
Headers.
want to show like the
Headers
query.
to the bottom. And double click this. Yeah, so this is the query itself being queried.
This will give back like all the data you need to build. I really like it because you get a lot of data and you can build amazing tools on it. And what we've built is just like one thing which you can do with GraphQL, but the possibilities are almost endless, because you can do these kind of things which are really hard to do in if you make a REST API, it's really hard to like enumerate every endpoint there is without somebody documenting that. And this is just, you get it back, you can do whatever you want. He made a D3 graph thing that made some big ass graph with the GitHub API. You know, I used the syntax tree for something, and we are looking into more ways how we can use GraphQL and these kind of specification, these kind of things to make new tools and kind of things that aren't really possible with REST.
It's just a query that says get the documentation.
Yes. Yeah.
And it's always there. You don't have to find it or something. You don't have to add doc blocks or JS docs like you have to do with REST or anything else. Okay. Well, I think there are questions. You raised your hand first.
Okay. Have you had any experience on how deep nested the queries can go with this left join?
Fun fact, yes, it can't really go because it will make like big ass table names, and like type ORM is what we're using as our ORM. At some point, like if you keep on joining, it will say like your table name is too large, so stop it. So it's like a sort of failsafe now, but we can we should be able to control like how deep you can go and these kind of things. That should be like easy to determine.
Was the end 5 levels deep or something, or how far could you go?
It's actually 6 levels deep or something that
I'm not sure.
When does it fail?
To show you.
You can just pull for another.
it shouldn't fail if you prevent the restriction on table names.
Yeah.
Oh, I think I did.
I think it will run indefinitely.
I think I didn't implement like the flights field on the airport, so I can't get back to the
Passengers?
Recursion.
I think I didn't. Passengers? Yeah, but I'm not sure if I.
Flights.
Flights, okay, yeah, I can go.
So the question, sorry for the streamers, the question is when using the AST inspection solution, is it then limited using joins?
So I requested the passengers, it's flights, and their departure airport, inside flights, so I'm kind of like getting all flights, getting all the passengers, getting all their flights, and then, but this data set is small, so it's not really a problem. But you can see like here, it's getting the passengers, getting the flights, and it's getting the departure airports. And I can keep people on going and doing the...
Can you query?
Logical to get.
Huh? Can you see the... Oh yeah, you can see the query, sure.
Rerun one more time?
No, I think...
Is the whole
Let
query?
me see.
Flights is not.
No,
using
I
it.
didn't implement the passengers the right way for the use. So if you look at it,
Oh, the passengers.
let me see. I'm not sure. Actually. No, it's still getting something from. I think I didn't implement the passengers right here. Oh no, it had to do with a many-to-many table. So we still have to look at how we're going to do it to join it with a many-to-many table. That's the problem. I figured it out earlier when I made this demo. But as long as you don't do many-to-manys, because type ORM does something special with many-to-many relations. Why?
You can use it together with a data ladder, I guess, to resolve some of that.
Also, that's actually quite smart.
Yeah.
Yeah.
Well,
Why not?
we should hire him now.
No, that's true. But it should be able to do a many-to-many as well.
Yeah.
We just haven't seen one.
So that's a good point of him. You can use data loaders and this AST solution at the same time. You don't have to choose. Yes. You.
Do you have any use cases already with this and like authorization on this one?
Well, with authorization are mostly done in, at least that's what we recommend, in the resolve function on a very low level? No, high level. So when you go very deep in a query, then when you, for example, request the name of a flight of departure airports of passengers of another flight of another airport, then you're very deep, and then to determine whether the user can access that, it is determined in the level, in the resolve function of the name That's what we recommend to do instead of completely upfront, because not embedding the name upfront could also mean that the optimization is not applied, not that the user may not retrieve the field. So we always recommend to do it on a very high level, just close to the definition where your field is. And then you can also inspect the AST to determine whether someone has access or not. And that's something else we have to look into.
Well,
That's,
yeah, like,
that's right,
like
the same.
Scoped end-to-end or scoped many-to-many relations. You have.
Yeah, it's hard.
But maybe you can eject maybe like a user ID or something
Yeah.
from the context or something. I don't know.
Yeah, you can determine it right there, but it's just as hard as when you are using data loaders, or it's just as hard as when you are using
Sure. Yeah.
anything else. So that's something that this solution does not resolve.
And another question, have you looked at, well, basically the IDs, or that you at least, get rid of, resolving duplicate records? So, for example, in the example that you use with the flights and the airports, so basically it sounds like a very silly problem because you have 3 of the same airports, right? 3 queries for the same airport with the same ID. So I've been diving a little bit into the Apollo link state and stuff like that, where they got rid of Redux, and then now we have this.
So
Some stuff that
the question is about client-side optimization.
Yeah, they're doing this client-side optimization by looking at the ID of your types, and then basically based on the ID they cache the types, or they cache the records actually.
Yeah, that still works.
That's so you could do a little something like that on the server side as well, I guess, right? So you only so if you have like one airport with the same ID, so you cache.
Yeah, well,
the
that's
airport, you don't load it
actually so. The question is about caching by ID on the server, and that's actually what the solution of data loaders is for.
Yeah.
So because the data loader just collects all the IDs and then resolves them afterwards.
Yeah, but it does that all the time. Does that for every
When-
query.
when
So
do-
there's like 3 consecutive queries doing the same thing, it will still do 3 queries. So I mean 3 different queries are still doing the same query to the same airport.
It shouldn't do any redundant queries when you're using data loaders correctly.
If there is multiple levels in the hierarchy, like we had the query now, where you start with flights, the airports, passengers, and then again airports.
Yep.
The date is done with the data loader. The data loader will remember, oh, I have already seen airport number 2
Yep.
previously, and resolved it previously, so I'm caching it.
Yeah, actually it works quite differently because it collects all the IDs up front.
No, you cannot always resolve all
then it
IDs
resolves all
upfront,
the
because there is
same time.
nested queries.
So,
There
sorry.
is a nested query in what
Yeah.
the last example is shown. You can only resolve the IDs up to so far, then you get more results, but then you cannot resolve the IDs of the airports
Because you're not there yet.
because you're not there yet, because you haven't resolved the passengers yet.
Yeah, that's true. That's the limitation of data
So
loader.
does the data loader then still cache for that
No,
set?
it's you to decide that, because you can put the data loaders in like a time-based cache, but you can also put the data loaders in a request-based cache.
Mhm.
And then every request will get a new set of data loaders to be shared within the whole query being executed in that request. But when you have a time-based data loader, then it will probably catch your problem too, because the query will be so fast that within the 50 milliseconds of resolving all the data, it will use the same cache. So even if the threshold is 50 milliseconds, then it would be really useful already. So that's up to you how you use the data loader. So maybe not by context, not by the context argument, but import it from a service which is time-based and recreates a set of data loaders every 50 milliseconds. That's up to you. So, but it's a good point. And I think that our solution of AST introspection also tackles that problem because it knows everything up front.
even if the query itself is
No,
by nature
it-
recursive.
It doesn't know everything up front, but it knows which fields are being called, and it joins the queries. So you don't need to do multiple queries at all. So that's really it. Yeah, somebody else?
I want to add that it's also possible to combine data loaders with caching in the resolvers. So it's possible that you get something from the cache, and if it's not present in the cache, then data loader will query for those IDs only. So maybe if half of the flights are already loaded, then only a few of them will be loaded with one query.
Yeah.
Also, the other thing is that with the joins, I would be a bit more careful because it also means retrieving more data from the database, and also sometimes some joins can be really heavy depending on your databases, and then actually the data loader method is much faster. Maybe if you use some relationship MySQL or whatsoever, then I would first really test which one works the best.
Yeah. So the point he made is that you always have to look what the best solution is. It's not one holy solution, and that's really true. Okay,
But is there a way that you can manage that on query level with your solution?
You can manage that on any level of fields. It doesn't matter how deep we are.
No, but you can choose whether you want to use the data loader solution or the join solution. That would be super interesting, because then you can just look at performance and then choose based on the queries that you have.
Yeah, that decision should have been made on the lowest possible level, because that's the location where you decide whether or not to join tables up front. That's where you have to decide whether or not you do that, and then in a deeper level you can always call the data loader.
You can do a lot of fun things. Like we are doing joins right now, but we could also make select statements on the fields that are queried, right? That's probably going to be a next step.
Yeah.
And
that is super interesting.
the main point is like, okay, we have that syntax tree, and we can do so much amazing things with that.
Yeah.
And just like the joins in this case, it's something we created quite recently, and it works pretty well for us right now. But of course, we have to iterate on that and create a way better version.
That's really interesting, but it also sounds like a problem that a lot of ORMs also have, right? And ORMs usually have the two cases. So you have the case where you basically say, I want to do it with the select. I'm going to select all the IDs that referring, or that refer to another table, and then use that as a select query for a second query. Or I'm going to use inner joins if I'm sure that I want to use both tables.
Yeah.
And the left joins, they create a lot more overhead, I think.
Yeah. So the get query from GraphQL info function could get a lot more smarter, but that's what he said. It's just has to evolve. Okay, so I want to wrap up the presentation, and there is a show and tell from Kim over there. He will show something about some GraphQL tools, and if there are any other people who want to show and tell something, I think that's possible. So let's take a little break first, just a few minutes to grab a drink, and then we'll resume with this talk. Thank you.